So by following this terminology, we will have to proceed. You will have to keep in mind that this is our top rung and this is our bottom rung. And only two rungs are in this ladder. As plus operate on chi plus, there is no more top rung than this one. So it will be 0, and there is no lower rung than this one. So this will be equal to 0. But what about the situation when S plus will operate on chi minus? What will be the situation? So we will have to come back to this equation. And from where this equation comes in, it also comes in from the mathematics of spin. We will not derive this relation, but we will utilize this relation. And look here, that this is equal to h bar. Now s into s plus 1. S in this situation, with either it is chi plus or chi minus, s is equal to half. So it will be equal to half into half plus 1. This is for s. Then minus s from the equation. But m for chi minus, m is equal to minus half. And then minus half for m, whether I will write plus 1 or minus 1. Plus 1, because for s plus we are having plus, and for s minus we are having minus. So it will be plus minus and half plus 1. And then this is under the square root. And here I will write s, and s is equal to half. So s is half, while m is minus half plus 1. Right? This is clear? So put the calculation into Greek. And we will have this thing equal to h bar. What will be this one? This is 3 by 2. 3 by 2 into 1 by 2. This is 3 by 4. And what this will become? 1 by 2 plus 1.
Minus 1.
It will become again 1 by 2. Because 2 minus 1, 1. 1 by 2. 1 by 2 into 1 by 2, 1 by 4, minus become plus. So this is plus 1 over 4 and square root. What about this one? It becomes half, and this becomes minus 1 over 2 into plus 1. Again, it becomes is half. Because this is 2, 2 minus 1, 1, 1 over 2. And this gives us 4, the LCM, 3 plus 1, 4. 4 by 4, 1. So we got h bar into half into half. What is this thing then? H bar, half is which state? Chi plus or chi minus? Chi plus. Right? Half minus half is chi minus. So what does this tell you? That when you operate S plus on chi minus, then it will give you h bar I plus. And that what I told you, that when you apply a raising operator on a spin down particle, it will give you an eigenvalue h bar in spin up particle. Clear? So similarly, you can prove that what S minus will give you. S minus will operates on chi plus. Because on chi minus I know that it will give me 0. But what it will give you on chi plus? So on chi plus it will give me h bar here. S and s plus 1 it will become 3 over 4. Then because s is the same for chi minus or chi plus. So this is 3 over 4. Then equation I will get minus m for chi plus is half, because I am taking chi plus. Again another m which is half, and then this minus I will take due to s minus. So minus and then 1. So we will have this under the square root, while here I will take half, and then m is half, m chi plus, so it will be half, and then minus 1. So do calculate this one. This will be h bar, and now this is 3 over 4. What will be this one? Minus half. Minus minus will become plus. So it is plus half, 1 over 4. And here, this one is half and minus half. So we got that this thing is h bar. Again, this is becoming 1, while the state has become minus. So we got that S minus will operate on chi plus. We get the eigenvalue h bar, and the state has been changed with chi minus. So we got 4 equations, and there are 4 unknowns as well in a given matrix: C, D, and E, F. So what we got, let me write this thing here, that we know is a summary here. In the summary, we know that because I want to write the matrix representation for S plus and S minus. So when S plus operates on chi plus, we get 0. And when S plus operates on chi minus, what we get? S plus on chi minus, we get h bar and chi plus. So we will have to write these in equations. The very first one that I write, S plus is C, D, E, F, unknowns. Chi plus is 1, 0, and it gives you 0. So what does this mean? When this applies, only C and E will remain, and this is equal to 0. This implies C is 0 and E is 0. Clear? And when I will write this equation, S plus C, D, E, F, when it operates on chi minus, which is 0, 1, it gives you h bar and 1, 0. Clear? H bar, 1, 0, chi plus. So this multiplication gives you C and E0, and only D, F remains. This is equal to h bar 0, and you got that D is equal to h bar while F is equal to 0. So your S plus comes out to be S plus is C, D, E, F, and this comes out to be, put the values, C and E are 0, D is H bar, so 0 and 0, D is H bar and F is 0. So this is equal to H bar 0, 1, 0, and 0. Right? So you got S plus is H bar 0, 1, 0, 0. Similarly, if I want to write for the other, and the other is S minus when operates on chi minus. So when S minus operates on chi minus, it gives you 0. And when S minus operates on chi plus, it gives you H bar chi minus. This we proved here. S minus on chi plus, H bar chi minus. So now put these into matrix form. C, D, E, F, the first one. 0, 1 is equal to 0. I have written this is minus no C, D, E, F, the same unknowns, and this comes out that D and F will remain, and we are having them equal to 0. So D is 0, F is 0. Clear? Simple mathematics. And when I write the second one, so C, D, E, F, when this operates on chi plus is 1, 0, we get H bar and chi minus, which is 0, 1. Here, what will remain? C and E will remain, and this is 0 and H bar. So it means that C is equal to 0, E is equal H bar. Right? So our S minus will become, S minus is C, D, E, F. This is equal, C is 0 and D is 0. E is H bar and F is 0. So this is equal H bar 0, 0, 1, 0. This is all S minus. Now we know that what is S plus? S plus is Sx plus I sy. And what is S minus? Sx minus I sy. So from here, I can write, if I add up the two, these two are cancelling, and this will become 2 times Sx, 2 I will move there. So Sx is equal to half S plus S minus. So I can write that Sx from here is half and S plus S minus, while Sy is 1 over 2i, because when I will subtract them, this will become plus, this will become minus, Sx will cancel, this will become 2 times I Sy. It goes here, so S plus minus S minus divided by 2i. So this will be equal to S plus minus this minus. Anyone who is not clear about this? It's clear? Simple addition and simple multiplication will give us the Sx and Sy values. So start from this one about S plus Sx. Sx is half, and here add the two matrices S plus and S minus. You know what is S plus. What is S plus? S plus is 0 H bar and 0 0 plus. What is S minus? S minus is 0 0 H bar 0 0 0 H bar 0, and this is equal to Sx is equal to half, and now add up the two matrices. 0 plus 0 is 0, then H bar plus 0 is H bar, 0 plus H bar is H bar, and 0 plus 0 is 0. And if I take H bar is common, then I will have Sx equal to H bar over 2, because 2 is coming from here. 0 1 1 0 0 1 1 0, and this is the value or the matrix representation of Sx, right? Sx H bar over 2 0 1 and 1 0. What about Sy? Sy from here is 1 over 2i, and then S plus is subtracted by S minus. So S plus is this one, which is 0 H bar and 0 0. This is S plus, and minus is minus 0 0 H bar 0. Right? So do their subtraction. 1 over 2i, and then the matrix will be 0 minus 0 0, then H bar minus 0 H bar, 0 minus H bar minus H bar, and 0 minus 0 0. Here we will do one tactic, and the tactic is, this is I. I want to move this I, as here I have written H bar over 2. I will move H bar out and I will keep 2 outside. But I want to put it inside. So, you know that when iota goes from the denominator to the numerator, it becomes minus I. Because how? If I multiply and divide this by minus 1, no problem. Here, minus 1 will become minus I. Here, minus 1 I write is I squared. And 1 I will cancel, the minus sign will go up and it will become minus I. So I can write this thing is minus I by 2. And 0 H bar minus H bar and 0. Can I write it like this? Okay. Then Sy is equal, take H bar out, clear? And minus I multiply inside. So it will be h bar over 2 and then multiply minus I inside. So we will have 0 and here as h bar is also 1 remains, it becomes minus I. This becomes plus I and 0. Clear? So this is the matrix representation of SY. And we have already done for the SZ. What was SZ? SZ was h by 2, 1 0 and 0 minus 1. So we are having Sx, which is different from Sy, which is different from Sz. Sometimes these are represented by sigma x, sigma y, and sigma z. And we call them the polyspinors, polymatrices. Okay? We call them as the polymatrices. These are also called the polyspinors because these are states, these are vectors, these are states. Like we were having spin up state and spin down states. These are also spinors, vectors, spinors, and these are also states. These are the eigenvalues. H over 2 being the eigenvalues. So we have derived the spinors, the polymatrices. Similarly, we will, in the next lecture, we will start with a given operator, for example, the Sx operator, and we will operate on a given state, given spin state, and then we will derive what will happen to the state and what eigenvalues we will get. Okay, thank you.